and welcome to another episode of the Kielder Observatory Podcast. Coming up in this episode, is there a twist in the search for alien life? We'll talk about that very soon. Also, why Elon Musk wants us all to move to Mars, and he wants us to do it as soon as possible. Well, any time in the next few billion years actually will be enough. And we'll look ahead to what the night sky may have in store at this time of year, and the events coming up at Kielder Observatory as well. All to come on this episode of the Kielder Observatory Podcast. I'm Ian Brannan, and I'm joined by Director of Astronomy at Kielder Observatory, Dan Pye. And Dan, as we move into this portion of the year, as far as being an astronomer is concerned, of course, you're sort of a little bit on reduced hours with the lighter nights, moving between May into June. Of course, the summer solstice around the corner. But that's not to say that there's nothing to see at this time of year, because there is joy to be found in the summer night sky.
There's still plenty of stuff to see during the summer, and I think that's something that we often overlook, is that the summertime doesn't mean that the sky just suddenly disappears and we can't see it because the sun's out, because there is still things that we can see. And interestingly, even though we are into the lighter nights, light pollution does still pose a problem for people living in cities. So you may even notice that if you were to come to Kielder and look up at the night sky, there will be more stars that you can see than you would have maybe seen in a big city as well. So it still affects us during the summertime, albeit that there's not a vast quantity of stars like there is during the wintertime to see, but there is still some really interesting stuff to look at. In particular, things like the moon. The moon's a great thing to look at. I love seeing the moon through a telescope. It was the very first thing that I saw through a telescope. I remember when I was a kid going to the Pontefract Observatory, as it is now called, the West Yorkshire Astronomical Society's observatory in Pontefract. That was my first observatory that I went to.
Wow. There you go. That sounds like a real, it's a really gritty place to start your astronomy journey, I think, isn't it? Let's come to the Pontefract Observatory.
I remember it distinctively as well. I can almost because I have this weird thing where I remember things with smells.
Oh, right, okay. How did it smell? Haribo?
No, interesting. It's the opposite side of town.
Right.
But the observatory, I remember going up these little stairs to have a look through the telescope, and I could see the moon. And I still to this day can visualize how the moon looked through the telescope. And we also looked at Mars as well. So the moon and Mars, and you know what, that was enough to set me off on my astronomical journey, was those two things. So looking at the moon through a telescope, amazing thing to do. Double stars, nice looking stars, the odd planet maybe, and the odd brighter structure as well. But the kind of jewel of summertime really is noctilucent clouds. I love noctilucent clouds. Arguably, I find them more visually spectacular than the aurora in some cases.
Wow, okay.
It depends how dramatic they get, though, because sometimes they're lesser animated than the aurora, because of course the aurora is a thing that's moving above your head, whereas with noctilucent clouds they're static, but they do look really cool when you get to see them in particular after about midnight. That's when they're at their best and they're shining very, very brightly. And these things, they're the highest structured clouds that we can see with the naked eye. They sit in a region of our atmosphere, and our atmosphere, it's made up of a few different layers. And one of those layers, the mesosphere, is quite high, 70 miles plus there or thereabouts. And during the summertime, it gets cold, really, really cold, as it does in that upper atmosphere anyway. Mm-hmm. And as a result, little ice crystals develop around particulates of dirt in the atmosphere, which is what causes any cloud. If we didn't have dirt in the atmosphere, we wouldn't have clouds. That's how a cloud is born, with lots of dirt. Anyway, these little bits of dirt are a little bit more special because typically these bits of dirt are as a result of all the 4 million pieces of dirt that are hitting Earth's atmosphere every single day. So all of this meteor debris that collects in the upper atmosphere, it crystallizes, and then as the sun moves into a position over the other side of the planet, or as we rotate away from it during the summertime, the sun's at this perfect angle where it illuminates this gathering of all of this meteor dust that's crystallized and creates these beautiful night shining clouds, or as we call them, Noctilucent clouds. So clouds don't normally shine on the nighttime, but they do during the summertime. And that's what we're looking at, these beautiful tendril clouds that have a kind of bluey colour to them. But visually with the eye, they look just as spectacular as they do on a phone, on a photograph, which is what I love about them. If you see a photograph of Noctilucent clouds, that's kind of what you're going to see with the naked eye. Depending on how big they are, sometimes they don't stretch all the way down above our heads. Sometimes they're just over on the northern horizon. But they start to pop out after, let's say, 10 o'clock. You might start to see some of them forming a little bit. And then as it gets to about midnight to 2 a.m., that's the real sweet spot for them. That's when they look their best.
Okay, so look out for the Noctilucent clouds then. And they are pretty spectacular. You notice them because, of course, you can see this cloud that's illuminated, late at night. It looks like a sort of bit more like a faint normal cloud. And they do catch your eye, don't they?
Yeah, they do. They do. Like I say, I just think they're the visually, for us in the UK, one of the more spectacular things to see. Certainly when you match it against some of the aurora displays that we get throughout the year. I mean, the aurora is an amazing thing to see, but sometimes people are underwhelmed when they first see it. They'll go, "Oh, is that it?"
Yeah, because sometimes, obviously, using your phone as well, people are expecting this big kind of show that they see on the, the pictures on the internet that usually you get from like the North Pole or whatever, and then it doesn't quite work out like that. It is spectacular. You hold your phone up, or you get a faint view of it, and you've got to get your eye in. I think sometimes. I mean, I've only seen the aurora that once or twice when it was mega strong. I've never seen it up at Kielder, but what I've sort of felt like it was a bit like those, those 3D pictures that you get, or used to get in the 90s, where you stare at them, and then all of a sudden you can see it, and it's a bit like that with the aurora. You kind of get your eye in, and then it's I can see it now. I can see that wavy line. I can see it, but it's not as dramatic to the eye as it is on an image, obviously, is it?
Yeah, no, it's not. And some of that is going to be down to your eyes adjusting to the to the darkness as well. There's a little reaction that takes place in your eyeball, actually. Let me just cough again. There's a little reaction that takes place in your eyeball when you get into a dark sky. Or when you get into any dark condition, there's a chemical in your eye called rhodopsin. And often people mistake this. They talk about the aperture of your eye getting bigger, letting more light in, and it does that very, very quickly. So your eye will open up and let loads of light in. But the problem is all of that light now flooding in is hitting the cones and rods on the back of your eyeball, which are collecting the light and then taking that and processing it through your optic nerve into your brain. But there's a little chemical which is responsible for changing the pigmentation of the rods in your eye, and this chemical rhodopsin changes the pigmentation of the rods in your eye to allow more light to pass, to be received by them. Which is what activates your night vision. Which is why when you look at an object directly and then you look away from it in a dark sky, you'll notice that looking away from it allows the light to be channeled through your eye towards those rods which sit around the cones. So you're kind of moving the direction of light through your eye to hit the rods instead, which are a little bit more sensitive to light. But they're not as good as processing. They're not as receptive to colour, so you get a lot of grayscale images instead of beautiful, colourful images through those rods in your eye. But that's how they work. And Allegedly, and don't quote me on this because, of course, I'm not a biologist, but apparently things like dogs and cats and animals have a lot more of these rods, and it's this and the chemical stuff which is quite reflective, and this is why we see their eyes glow when we shine lights on them.
There you go. Turn into a biology lesson. The eye rods.
The eye rods.
The eye rods.
It was my optician that taught me all of this, actually.
Oh, well,
when he found out I was an astronomer, he was like, "Oh, give you a lesson on how dark adaptation works."
I tell you what, while you're here, I've been desperate to tell about these eye rods. You might appreciate the story.
Thanks to Paul from Vision Express.
There you go. Vision Express. So something that I think it just sort of started coming out the last time we did a podcast. I don't think we really talked much about it, but going back to last month, there's this news about the James Webb telescope and what it's found, and it's picked up the signs of molecules that on Earth are produced only by living organisms. Researchers are involved in this now, and we're going to find out, obviously, in good time what it all means. But this could be the discovery we've been waiting for of some kind of significant life of some sort or size. Not well, a fair way from here, but that said, obviously, reasonably, I think on our doorstep. It's not in the depths of space, is it?
Yeah, no, it's not too far away. I forget how far away it is actually, but is it 160 light years? Let me
have a look.
Or 600 light years.
It's quite a big difference between 600 light years. that's a good 500 light years to wait. 124 light years.
124. There we go. Oh, it's not too far away then. Yeah, it's practically just around the corner. And the chemical that we're looking at here is dimethyl sulphide, which it's not the first time that Webb's spotted dimethyl sulphide. It's been spotted before in tiny trace quantities that wasn't really strong enough evidence to suggest that it was actually in the atmosphere. It could have almost been a calibration error or just an anomaly. Whereas this looks to be in much larger quantities. Dimethyl sulphide is something that has been spotted appearing as a result of natural causes. So stuff like comets, for example. Comets, we've seen dimethyl sulphide on comets as a result of the geological processes that are happening in comets. So it's not solely a thing which life is responsible for producing, but typically in a geological sense, it tends to be, from my understanding, again, I'm not a geologist either, but from a geological sense, it's usually in smaller quantities than what it's been observed, which suggests that perhaps maybe this could be coming from some kind of organic origin. So very, very exciting. Take a long time to get to any kind of conclusion. Whether or not that conclusion will ever be comfortable with that conclusion, I'm not convinced, because I feel like it's one of those things that people are just going to argue about for eternity until we have some actual physical evidence that there is in fact life on their planet. By whatever means they use to detect it. But I think it's always worth having that open mind, and also remembering that science is often about getting things wrong and then finding a route to get it right.
Yeah. I mean, looking at it now, I just thought I'd just have a quick look and see if there's any sort of further movement on this. And it's all come from data from James Webb and how that data is interpreted and analysed and so on. But there does seem to be a bit of a disagreement between the team at the University of Cambridge, who are the people who made the global headlines when this was announced. But then I think the University of Oxford have had a look at the same data and done their own study, and they're a bit more kind of on the fence and circumspect about it. That it, it might not be what they think it is. So obviously this is going to go on for a while now with various people who are cleverer than I, who are looking at the data and trying to work back what it might suggest. But seems the jury is out, as that it may not be what they hoped it to be yet. But as you say, this is sometimes about getting things wrong, and until you get it right. So we don't know.
It's the story of science. Get it wrong until it's right. But often getting it wrong just it creates loads of different pathways and new technologies and new ways of looking at things. But I always think it's worth just always having that open mind about anything. If you the second you start to reach a point where you're like, nope, this is impossible, I kind of feel like your creativity's gone now. Yeah. Are you really still a scientist? Are you really still scientifically minded if you're starting to rule things out with a very, very hard yardstick? But I don't know. I'd say it's a complex field and something that, I mean, I don't really do any science whatsoever. I just talk about it. But we're going to have to change the name, though, if something does transpire to be potential life, rather than K218b. I think we need to change the name.
Yeah. What would you change it to? What would it be named?
I don't know. Jeff.
Yeah, Jeff. There it is. Just Planet Jeff, floating there, 124 light years away, just on our doorstep. Something else regarding planets, and also the jury being out, is Elon Musk has said that eventually all life on Earth will be destroyed by the sun, and that is why we need to set up life on other planets. I think, obviously, the elephant in the room there for me being that if we get to the point where the Earth is swallowed up by the sun, then surely being next in line, Mars would also probably be not an overly pleasant place to be by that point. But that's a fair way off yet. And I think Elon Musk probably jumping the gun a little bit because it's not likely to happen next week.
Yeah, I think he's really looking. He's really got an eye on the very distant future. I mean, that process isn't, to our knowledge right now, going to happen for quite a few billion years. By which point, who knows what would have happened to civilization? Looking at it right now, it might not get that far. But
yeah, Tesla won't be still operating by then. That's pretty sure.
So I can see what he's trying to do, and I can understand what he's trying to do. And there's not all bad in this. It's sensationalized by the media quite a lot, and they try and villainize these people. And there's a lot to be said about Elon Musk separately and politically. And to be honest, quite frankly, I don't want to get into that or care about it right now. But the one thing that these kind of people do have about them is that they push us forward with the way that we approach technological feats. We move into a realm of having to break technology almost to achieve these goals, and that's what gives us a payoff for humanity. Ultimately, things like the mobile phone, and we've talked about it before. Things like the mobile phone, pacemakers, two-way radios. Practically every item in your house that's electronic comes as a result of us trying to break technology to get into outer space and figure things out while we're there as well. Your digital camera. I mean, digital cameras were used by astronomers years before they even reached the domestic market, because when you get into outer space, processing film's pretty difficult.
Yes. There's no snappy snaps on Mars.
No. So these things, they do have a very significant payoff for humanity. It's not just about egotism or colonialism. It's about the journey that we take to get to these places and what that means for our human life here on Earth. So there is a kind of silver lining to some of it as well, which I think often gets overlooked by, again, this trying to make these people look like James Bond villains or whatever.
Yeah. He's Elon Musk has said that we have about 450 million years before it gets so hot that life is impossible. Now, 450 million years ago from today would be the Ice Age, so it's not like imminent. But I guess what he's saying is that we've got 450 million years to get our act together and get to other planets. But obviously, that's obviously his mission at the moment. But again, it's something that's not going to be very easy, though, is it? And 450 million years, a lot is going to happen in that time. It's safe to say. And maybe we will be all living on other planets by then. Who knows what will happen in that time? But obviously, I don't think he's making a case that SpaceX needs more funding. Basically, I think through this to try and save the world in 450 million years from now, where some kind of robo effigy of Elon Musk will be there to take the credit, even that far into time. Who knows?
And then there's the question about evolution as well in this, because we kind of look at that 450 million years into the future, humans are going to be exactly the same as what they are right now. That's not necessarily the case. I don't think, and again, we need a biologist on this on this show to talk to us about this. But as far as I know, there's no evidence to suggest that we are at the end of our evolutionary process. We'll continue to evolve. In fact, we're not very well evolved to begin with. If you think about the lower back pains we all start to develop as we get older, because we're not meant to be bipedal, and all of the other things that are broken with humans that haven't evolved very well. So in 450 million years' time, humans may have evolved to live in these conditions that the Earth is. It could be that we've all just become big puddles of blib on the floor, and that's how we exist now, is just these big puddles of stuff. It could have changed entirely. I was thinking about the South Park episode now, where all humans are the same. There's no difference in colour. There's no difference in language. Every single human is exactly the same, because we've all
evolved into one big blob.
Or just become just one generic thing. But it kind of reminds me also a little bit of something Carl Sagan talked about, which was about intelligent life and leaving the planet. And he strongly believed that if an intelligent life form was to come to our planet, they would have had to have solved all of these different conflicts across their own planet to be able to build the technology and achieve the technological feats that are required to make it across interstellar space to another world. By being unified in their thinking, by being unified in their technological growth. So maybe we'll reach that point at some point. Maybe we'll stop fighting each other. Maybe we'll start to work more harmoniously as an entire planet. And maybe only at that point is the time that we're able to really start to solve many of these problems. Who knows? I don't know.
Yeah, that was pretty deep for this particular podcast, I have to say. But
it was. And it's not going to be Carl Sagan now who said that, is it? But I'm pretty sure it was.
Yeah. Well, now it's Dan Pye who said that. People will remember it. Let's have a look at what's happening then in May. A few things have already happened, but one thing that seems to be fairly present for a good proportion of it is the go on, how do you pronounce it?
Eta Aquarius.
Eta Aquarius, that one, is at its maximum. And that seems to be sort of on the go for quite a bit of May, doesn't it?
It is. It's not really a Northern Hemisphere meteor shower, this one either. Right. It's something that often ends up in news feeds on Facebook of like, oh, the sky's going to light up with fireballs. Yeah, it's not. It is, however, the tail of Halley's Comet. That's what we're moving through. So it is a relatively topical subject to talk about because we're in the debris trail of Halley's Comet. But yeah, it's more of a southern hemisphere-centric meteor shower, but it's not to say that we don't get meteors that you can see as a result of that from here in the northern hemisphere.
Okay, so there might be the odd one, but don't spend too long out in the garden staring and waiting for it to happen, because you might be waiting a while, unless, of course, you're living in, I don't know, Bolivia or somewhere like that. Venus is reaching its greatest western elongation right at the end of the month as well, so that's one to watch out for.
Yeah, so this one means that it's visible in the morning before sunrise. Just the furthest it is away from the sun at the moment.
And then, really, it gets a bit more difficult then, doesn't it, for the casual stargazer heading into June? Of course, the lighter nights, and we don't really get full darkness, I guess, particularly in our location in the north, right up in Northumberland. Of course, it barely really gets dark.
Yeah, that's it. We're kind of out of that really good dark sky weather time of year now. And frustratingly, this time of year is when the Milky Way comes back into its best view. So right in the southern part of the sky, Aquarius starts to rise and Scorpius, and we get to see the Milky Way stretching right above our heads and falling into the northern horizon. So this lovely band of light that stretches around us. And best time of year to see that, but not in the northeast. We do see it a little bit after about maybe 1 o'clock in the morning, 1:30 in the morning for a short window right now, and then it disappears and comes back when we start to get into the end, mid-August, there or thereabouts. And this is best viewed really from maybe the southern parts of the country, so head down to places like Cornwall, but it's still quite light down there as well. So my advice, if you want to see the Milky Way at its best at this time of year, is to go to Tenerife. Go to Tenerife, because an amazing dark sky there. If you go up the mountain, Mount Teide, you'll get a wonderful dark sky, and because you're just that little bit further south, where you're about 33 degrees down there as opposed to 55 that we are up here in the north, and so you get still dark skies at this time of year. So you'll see the Milky Way stretching above your head, and it starts to come out. In fact, because it's nice and dry there, as a result of some rather unique wind patterns and just the dryness of it being off the coast of Africa as well, you get to see the Milky Way starting to pop out just as the sky is even still a little bit blue, which is something I've never seen before other than in Tenerife. So yeah, worth going on, worth booking your holidays to Tenerife this year just to go and see the Milky Way. But of course, do it when there's no moon in the sky, because the moon's going to prevent you from being able to see it.
And then looking at events coming up at Kielder Observatory, of course, as we mentioned, because there's obviously a bit of a break, I think, in proceedings at Kielder Observatory, isn't there, in the summer? So you're having a bit of a week or so off right in the middle of the summer. But that said, there are plenty of other events going on right through the summer, particularly, I think, the family and the kids events looking ahead to the school holidays.
Yeah, that's right. We've got a short break in June where we close down for maintenance and spruce everything up, fix things that have broken over the winter time, and this year as well move office. So we're moving our office from where it's currently situated to a new one. So lots of change happening this year, and there is plenty of events still on the calendar. When we get around the solstice time, that's when we start to do mostly late night events, because that's when it's going to be the darkest time of night. Then we break for a week, come back, do a few more late nights, and then as we start to get into July, the kids program really starts to kick in. And that is incredibly popular through the summertime. We tend to completely sell out through July and August. So if you're looking at coming to Kielder or attending one of those events, my advice is book it now while they're still available. We've got things like rocket launching that we bring back at this time of year. I love rocket launching. It's the best kids activity that we do, launching rockets. So those are on the calendar now. And also the events from September onwards are on the calendar now as well. Few changes come in. We're always working to improve events. So there's new improvements being made to events, and we're reducing the capacity as well on events from September onwards. So we'll have fewer numbers on events, and this is all reacting to feedback from guests. We listen to guests' feedback. It's one of the most important things to us is to take people's feedbacks, find out their expectations, and adapt what we do to meet their expectations and to keep working on the quality of the product that we produce. So plenty of changes happening with that from September onwards as well.
And all the events are available on the website now, right up until February next year at the moment. Yep. You can book up until, and you'll be able to see the different events that are going on, obviously different times. There's some late night events. There's Oranges in the Universe. There's Secret Life of Stars. Oranges of the Universe. The Aurora Night, of course, which doesn't guarantee that you're going to see the aurora, but gives you the skills. But hey, you may look out and you may actually get both the skills and see the aurora as well, because you never know. And then lots of kids events as well, as Dan was mentioning there, particularly through August. There's loads of them right through the 6 weeks holidays. Get on and get booking. Right, well, with that, we shall get back to our telescopes. Thanks for joining us, and we'll see you on the next episode of the Kielder Observatory Podcast. Through the telescope. No, that sounds a bit creepy. Anyway, we'll see you next time. Bye.
Bye.